So in this recording, we're going to be looking at working through the worksheet that you've been allocated to explore and consolidate your understanding of sine. So for example, if we start with the first question, you're asked which acronym we use to remember our trigonometric ratios. So I'm just going to highlight that, and it's really important that you do try and remember the acronym because it will help you learn which of the features of a right angle triangle are required for each ratio. So we call it SO, KA, and then TOA. And what that basically tells us is, so let's focus on tan, for example. So that tells us that we're looking at using the ratio for tan, and in that we need to have an opposite divided by adjacent. So keeping that in mind, let's have a look and work through this particular worksheet. So the first thing in question 2 we're asked to do is label all of the sides of the following triangles. So the first thing here is you need to take care and notice where the reference angle is, and I've just circled that in blue, but I might highlight it as well. That theta there represents our reference angle. And the reason that that's really important is because your reference angle will determine where your opposite and your adjacent are. So let's label what we know for a fact. We know that the longer side of the right angle triangle from our work in Pythagoras is known as our hypotenuse, so I'm going to call that H. Then the other feature about a hypotenuse is that it's actually opposite the right angle. So that's just another way of remembering in case you forget that the hypotenuse is the longest side of a right angle triangle. Then let's have a look at labeling our adjacent. So one of the features of our adjacent is that it's next to our reference angle and next to the right angle. And then lastly, the side that is opposite our reference angle is also known as our opposite. So that's going to be labeled with the letter O. So please keep those in mind when you are looking at labeling the sides of a right angle triangle, because it will help you identify which of the ratios you need to use when you're asked to find the length or calculate an angle for a right angle triangle. So I'm just going to quickly go ahead and label the sides of these right angle triangles as well. So I'm going to stop writing adjacent and hypotenuse and opposite. So A represents adjacent, H represents hypotenuse, and O represents opposite. So question 3 asks us what angle option we must make sure our calculator is always set to. Just in case you've forgotten, it must always be set to degrees mode. So make sure that your calculator is set into degrees mode, because if it's in radians, which is usually represented by an R, you're not going to get the answer that you're required to have for this particular set of tasks. All right, so moving on to the next question, we're asked what sine of 30 degrees is. So I'm just going to pull out my calculator and let's have a look at it. So sine of 30 degrees, and that's equal to 0.5. So I'm just going to write my answer here. That's equal to 0.5. All right, so let's move on to the next page. So question 5 asks us to find the length of the opposite side. So the big hint here is that we're looking for the opposite. We know that because we're using the trigonometric ratio of sine, our general equation is sine of an angle equals to the opposite over hypotenuse. So we're looking for the opposite. So that means by theory, or in theory, we should have our hypotenuse given to us. So first things first, I always encourage everyone to label their sides. So let's start with our hypotenuse. We know that x is our opposite, and we've got a reference angle of 50 degrees. So here I'm going to write sine of 50 degrees is equal to x divided by 17. So now what I'm going to do is I do need to do a bit of pre-work to this particular equation before I type it into my calculator. So what I'm going to do here is multiply both sides by 17. So that way I can cancel it from the right hand side and make sure that my entire equation is something I can put into my scientific calculator. So looking back at my calculator now, so if I do 17 times sine of 50 degrees, I should be able to work out what my opposite is. And my opposite length here is that x is equal to 13.0, let's say 02 meters. So here what I've done is I set up my equation and then use that to find out what my opposite length is equal to. So I'm going to do the same for the next two examples. Try and follow along with the working out. If you did get them wrong, maybe go back and try the questions again now that you have the work solutions here. Question 6. We're asked in each of the triangles from question 5 to use Pythagoras' theorem to find the third length. Now I haven't left myself enough space on this one, so I might do the working out. I might just condense the working out so I've got a bit more space. So I'm going to use pink for this one. So Pythagoras' theorem tells us that a squared plus b squared equals c squared. So in this case, we know c squared is the hypotenuse. Oops, sorry about that. So then we've got 13.02 squared plus b squared equals 17 squared. Now, what's happened here is there is the adjacent side that we don't know the length of, and that's what we're trying to find. So I'm going to rearrange this equation now. So b squared is equal to 17 squared minus 13.02 squared. So then b squared is equal to, I might just chuck that into my calculator. And I end up with 119.48. So now what you're going to do is go b equals to the square root of 119.48. And again, putting that into my calculator. So if you look at the screen now, I'll do the working out here. So we've got the square root of, put a square root inside a square root. So 119.48. And that gave us a length of 10.93. Now, the context of the question, all the lengths are in meters, so I'm going to give my adjacent in meters as well. So what we've just worked out is that our adjacent side, so the side I'm writing in pink, is 10.93 meters in length. So what I'm going to do now is go back to questions B and C and use Pythagoras to find our adjacent side. In case you're wondering where the working out for the trigonometry aspect has gone, I've just shrunk it and moved it off to the side, so I've got enough working out space. I'm still going to do the calculations for Pythag using the hot pink color, so just try and follow along. All right, so now moving on to question number 7. So we've been asked to find the length of our hypotenuse in each of the following triangles. So I'm just going to highlight that because I think that's really important to remember. We're looking for our hypotenuse. So again, even though this whole tutorial is based on using sine, I'm just going to label my sides anyway, because later on you will be progressing to questions where we haven't told you which ratio to use or what information you have. We'll just give it to you and you need to work out whether you have an opposite side or an adjacent side or a hypotenuse given to you. So T here is going to be our hypotenuse, 29.52 is going to be our opposite, and the other side is going to be our adjacent. So we know that when we use sine, for example, we're looking at our ratio which says so, and that means that it's sine of the angle is equal to the opposite side divided by our hypotenuse. So again, filling in the information that we have, so sine of our reference angle, which is 72 degrees, is equal to 29.52 divided by t. So in this particular instance, there is one more step we need to do. So I'm going to start by multiplying t from both sides to get rid of that fraction there. So that cancels out. And then what I'm going to be left with is t times sine. Actually, I might make that a little bit clearer. So t times sine of 72 degrees is equal to 29.52. Now, again, here we've got an issue. We can't actually just type this into our calculator, or at least our scientific calculator, so we need to do one more step. And that is to actually divide the left-hand side and divide the right-hand side by sine of 72 degrees. So doing that will simplify that to 1. So that'll be t is equal to, and now if we flick back to the calculator, so I'm just going to set up a fraction. So if you press that button, it'll bring up a fraction. It's 29.52. Divide that by sine, so I just press the button, of 72 degrees. And don't forget to close that bracket. And we get a length or a hypotenuse of 31.04 meters. So I'm going to do that now for the next set of questions. So just follow along and check your working out to make sure that they do match. If there's any mistakes, maybe have a go at pausing the video and trying the question out again to make sure that you do know. So now we're going to move on to a worded question. So we're told here that a man is standing in his backyard and looks up to see a hot air balloon flying by. If the angle from his feet up to the balloon is 49 degrees and the distance in a direct line from his feet to the balloon is 4.8 kilometers, how high above the ground is the balloon? Answer in kilometers, correct to 2 decimal places. So I'm going to go back now and just highlight some key information in this question. So one is that the angle from his feet to the balloon is 49 degrees. It's in a distance in a direct line from his feet to the balloon. And we're asked how high is it? Give our answers in kilometers, correct to 2 decimal places. So what I like to do with worded questions is to try and draw out the situation. It usually helps me to put together my thoughts and understand what exactly it is I'm looking for. So I'm going to draw this out in a diagram. Excuse my terrible drawings. So, draw the hot air balloon. Might just label that because it doesn't really look like one. Alright, so distance from his feet to the balloon is, we're told, 4.8 kilometers. And then obviously the angle that it makes with the ground. So I'm just going to draw that out. So his foot to the ground, we're told is 49 degrees. And then I'm just going to complete this right angle triangle. So now drawing that line down, we can see that that is what's going to form my height. In the question, we're actually asked as well, how high above the ground is the balloon? So I'm just going to label this as my ground. So now if we go back and actually label these sides in the way that we have with previous questions, we can see that the 4.8 kilometers forms our hypotenuse, and the height is actually our opposite, because notice that it's opposite to our reference angle. So now I'm just going to pick another color to do the working out in for this particular question. So we're going to be using sine. We know that sine of theta is equal to opposite over hypotenuse. So here I'm going to write sine of 49 degrees is equal to our height, which I haven't specified. So let's call it h. So I'm going to call it h over 4.8 kilometers. So now what I need to do is obviously move that 4.8 to the other side so that I can solve for h. So given that it's divided by 4.8, I'm going to multiply to get rid of it. So if I do that to the right hand side, I need to multiply the left hand side by 4.8. So that leaves me with h is equal to 4.8 times by sine of 49 degrees. So now just pulling out my calculator, let's type that in. So 4.8 times sine of 49 degrees, that's going to give me a height of 3.63 kilometers. So as you can see, the hot air balloon hasn't traveled very far, even though the hypotenuse makes it seem like a little bit further away. Realistically, the hot air balloon, I just realized I spelled balloon incorrectly, my bad. We can see that the hot air balloon has only risen 3.63 kilometers high above the ground. So hopefully now you feel a little bit better about using sine to calculate your unknown sides. Again, if there's anything you got wrong in this worksheet, now's the time to actually go back, look at your mistakes and figure out what happened and where. Now that you have work solutions as well, you can always compare your working out with what I've given you and determine where your mistakes were. And don't forget to ask for help if you're still stuck.